Okay, so the question is, S and T are independent. S is 0.65. P of S and T is 0.28. We need to find P of T. And then P of S given T. So, I was reading your work, or what you wrote in your message. I'm going to try to use the same formulas you did at the beginning. So it looks like you worked with P of S and T. And I think you had the right idea. In the notes, you have a section that says 2 events are independent if the following are true. And if we translate it into the letters that we have here, it would be P of S and T is P of S times P of T. So it looks like that's where you started. And you took your best guess, and I think it was a fabulous guess. I think you did really well. You just didn't have the confidence that you needed. So once I write the formula, I'm going to plug in the things that I know. I know S and T is 0.28. I know P of S is 0.65. And I'm going to call the probability of T X. You could call it G or Y or Z, whatever you want to call it. I'm just going to call it X. So it looks like what you have is a very innocuous little algebra equation here. It shouldn't be too bad. If I write it so it's not all spaced out, and I like my X's on the left instead of on the right, if at all possible. So what it looks like you have is 0.65x is equal to 0.28. Now in algebra, we talk about isolating the variable by using inverse or opposite operations. We want to isolate, as Bob Ross would say, our happy little X. We want X all by himself. And that 0.65 that he's multiplied by is in the way. So to undo this multiplication, the opposite of multiply is divide. So instead of multiplying by 0.65, we want to divide by 0.65. And if we do it on one side, we have to do it on the other. And every time I say that, somebody says, Miss Graham, I don't see the sides. If you don't see the sides, it's totally fine. Draw a line down your equal signs and make yourself 2 sides. So you can see you divided on both sides of that light blue line. When I do that division, my 0.65s are going to divide out. I could go into a big old story about why those divide out. It's really not important. If you decide you want to know, let me know and I'll go deeper. I'm really just left with an X on the left. And then because I stink at mental math, I'm going to pause and pull up my calculator. And I get 0, what do we need? 4 decimal places. So 4307. And the number after that is a 6. So this is my probability of t. We want it rounded to 4 decimal places. So 1, 2, 3, 4. Now I go next door to the right. 6 is bigger than 5. So my 7 rounds up to an 8. So the official probability of t would be 0.4308. So there's your p of t. So now let's go look at the other piece of this. P of s given t. I'm going to go back to my list of formulas where it says 2 events are independent if the following are true. And there's one that says P of A and B, in our case, P of A given B is equal to P of A. In our case with our S and T, that would translate to P of S given T is P of S. Quick, well, nothing I do is ever that quick, but a little bitty side note. If you have trouble going from A's and B's to S's and T's and making sure you have the things all in the right order, you can always replace those letters with something else. You could say P of the first thing given the second thing equals P of the first thing, as long as your events are independent. So you can replace those letters with any words you want. If you want symbols, you can put symbols in there. You can put hearts and smiley faces. I don't care, as long as you get them in the right order. And sometimes the words, the writing out first thing, second thing, first thing, makes more sense in my brain than just using the letters as placeholders. But anyway, when I want the probability of S given T, and remember this only works for independent events, is the same as P of S. And that means both of these are equal to 0.65. Hope this helps. If it was not quite as helpful as